good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever. And today we are talking about quadratic functions. You're tired of them. You should be. This should be review for you. Quadratic function is in this form, which we have discussed extensively. Mama quadratic is y equals x squared. And we can base graphing of all of our quadratics off of y equals x squared. Because we can transform it, we can stretch it, we can shrink it, we can dilate it if we want to. There are many ways to graph it. That's probably one of the most effective ones. If you weren't aware, a parabola is a conic section, meaning that is formed by slicing a cone. There's a nice illustration of that right here. You take a plane, slice it through a cone, and the resulting shape is a parabola. Just some terminology in case you've forgotten it. The actual graph is the parabola. Parabola has an axis of symmetry that cuts a parabola exactly in half. It's symmetrical on either side of the axis of symmetry, and the axis of symmetry acts as a mirror. The minimum in this case, with the parabola open upwards, is the vertex. Y-intercept, you should already know. It's where any graph cuts the the y-axis, and your x-intercepts are where the graphs cut the x-axis. We call them zeros. They also give us solutions to the parabola. Oh, I'm not sorry, to the parabola, to the quadratic equation that is the graph. So we can find the zeros. I'm not going to go through this. It's a lot of common sense, really. Let's see. There is something with the axis of symmetry. It's always going to be halfway between the zeros. So with a parabola, you can either have it intersecting the x-axis in two spots, and touching it exactly one spot, or not touching at all. This would correspond to two solutions, two rational solutions. I take that back, two real solutions. They may or may not be rational. This would be a double root right here, and here would be no solutions because it doesn't touch or cut the x-axis. If a, the coefficient of the squared term, is positive, our parabola opens upward, and if it's negative, it opens downward. And let's see, what else do we want to talk about here? Okay, moving on. Using axes, intercepts only, sketch the graphs of y equals 2x, 2 times x plus 3 times x minus 1. So we're going to find some intercepts here. To find the y-intercept, we just let the x's equal 0. So if x is equal to 0 here in A, that would turn into 2 times 3 times negative 1, which is negative 6. So I know that this parabola intersects the graph, the y-axis, at negative 6. 1, 2, 3, 4, 5. That's negative 5, so we've got that right here. And then to find the x-intercepts, I'm going to let y equal 0. And remember, we find these intercepts because if a point is on the x-axis, its y-coordinate has to be 0. So if we let y equal 0, we'll find out when or where it cuts the x-axis. So in this case, using ZPP, yeah, you know me, I get x is equal to negative 3, or x is equal to 1. So 1, 2, 3, 1. Okay, so we have a pretty good idea here. And remember, our axis of symmetry is halfway between these 2 points, so that's going to occur at negative 1. So this is the axis of symmetry of the parabola. The vertex always lies on the axis of symmetry, so we can get a pretty nice sketch right there. Okay, same thing here. Let's see, if I let my x's be 0, I have negative 2 times negative 1 times negative 2, which is a negative 4. So that's my y-intercept, 1, 2, 3, 4. And we'll say this is -5. And then if I let y equal 0 and solve for x, I get x is equal to 1 and x is equal to 2. So this is a bit of a weird parabola, except if we're thinking it opens upwards, then we're having some issues there. But since it has a negative coefficient here, then we know it's going to open downwards. And so our parabola is going to look like, so it's going to open downwards. The axis of symmetry is halfway between the x-intercepts. So it's going to be at between 1 and 2. Oops, that was a bad line. I don't care. X equals 1.5. Whoops, that's a bad 5. Okay, so it's going to look like something like that. The axis of symmetry, I messed it up, but it's right there. I forgot to write the equation over here. This is going to be x equals -1. And finally, we'll do this one, y equals 1/2 times x plus 2 squared. If I let x equal 0, that's 1/2 times 2 squared, which is 1/2 of 4, which is 2. So let's see, y-intercept of 2. We have a positive coefficient here, so it's opening upwards. And if I let x equal 0, then I get x plus 0 equals x plus 2, the quantity squared. Square root of 0 is 0, so x equals, or 0 equals x plus 2, taking the square root of both sides. X equals -2. So that means, since I only have one x-intercept, that means the graph is going to touch the x-axis right there. So our axis of symmetry is x equals 2. The other thing, I should have done this over here, now that I'm thinking about it, but a parabola is symmetrical about the axis of symmetry. So since I have a y-intercept of 2, and it's 2 units to the right of the axis of symmetry, I know I have another point 2 units to the left. And I can use that point to do a better sketch, and there we go. Okay, so what do we got next? This is what we call vertex form. This is in the form y equals a times x minus h, the quantity squared, plus k, where hk is the vertex. Okay, and that's what form this is in. So my vertex, notice that this is a minus, so since this is a plus, my vertex is at -1, and my k is 4, so it's at -1, 4. So -1, 1, 2, 3, 4. It is a negative coefficient here, so I know I'm going to open downwards. And all I really need now is a y-intercept. I don't even need the x-intercepts. So to find the y-intercept, I let x equal 0. So that would be -2 times 0 plus 1 is 1 squared plus 4. So -2 plus 4. -2 times 1 squared is -2, plus 4 is 2. So I have a y-intercept of 2, 1, 2. This is my vertex, so I know it's my axis of symmetry as well, or I know that my axis of symmetry goes through it. The equation of the axis of symmetry is going to be -1. By symmetry, since I have a point here, it's the same distance away from the axis of symmetry, and it opens downward, and I can get a nice, beautiful sketch. All right, let's see what's next. Determine the coordinates of the vertex y equals 2x squared minus 8x plus 1. Okay, so I'm not going to show you the proof. We can talk about that in class, but we can get the equation of the axis of symmetry is x equals -b over 2a. Okay. And since remember, so this could be the axis of symmetry, and since the vertex is on the axis of symmetry, the x coordinate is -b over 2a. Okay, and that's when we're in the form of ax squared plus bx plus c. So my x-coordinate in this case is going to be negative 8 over 2 times 2, which is, well, thank you about that. Thank you, Miss Hughes. Negative 8, or I have a negative out here, over 4. Negative times a negative is a positive, so that gives me 2. So I have an x-coordinate of 2. And to find the y-coordinate, I just need to substitute back in here. So that would be 2 times 2 squared minus 8 times 2 plus 1. So 2 squared is 4 times 2 is 8 minus 16 plus 1. Negative 8 plus 1 is negative 7. So the coordinate of my vertex is 2, negative 7. And just to prove it to you, I'm going to graph it. Fire up the graphing calculator, the TI Inspire, two blows, and here we go. 2x squared minus 8x plus 1, bam. And I'll pull and move that up, and we said, oops, no, I want to pull this and move it up. Okay, we said the vertex is at 2, negative 7. You can kind of see that right here. I'm going to prove it to you and also show you how to find a minimum on a graph. Analyze a graph, find the minimum. I go to the left of the minimum and then to the right, and there it is. Okay, let me put that in your notes for you. There we go. And I think I'm going to cut it off here. We have a little bit too much to do. Well, hold on. We have a little bit too much to do do more of a video. So we'll split it into 2 parts. There you go. Hope you enjoyed it. I certainly did. And I am out until next time. See ya!